Assalamualaikum everyone. Hope so you are doing fine. So in the today's lecture is very important, and in this lecture we are going to cover about 12 practical of organic chemistry in that single lecture. So in this lecture we are going to discuss about the identification of the following compounds which are written here. We are going to identify benzoic acid, benzamide, urea, thiourea, tartaric acid, salicylic acid, citric acid, cinnamic acid, oxalic acid, glucose, fructose, and sucrose. So, in this one video, you have to cover all of these compounds, and we discuss how we can identify them and what types of tests we should perform to identify them. Okay, so if you have not subscribed to my channel, please go and click the subscribe button to get all the videos for all the students, and also press the bell icon to get the notification of all the videos which I have uploaded. So I hope so that you have subscribed this channel. If you don't subscribe this channel, then go first and subscribe it, because you are missing this opportunity to get this lecture, so and other important contact for my video and my channel. So go and subscribe to my channel, and then we should start the video. So in the start of video, first of all give the trick to remember all the structures of this compound, because you have to remember them and you have to draw them in your experiment. So you have to know what is the structure of a particular compound. So if you know the benzoic acid structure, the structure of benzoic acid is so simple that it simply consists of a benzene ring, and it has a carboxy group on its upper part. If you know the benzamide, it is quite similar to the benzoic acid. In benzoic acid we use this CHO group, but in the amidic group we change this group by CONH2 group. So this is the difference between the benzoic acid and the benzamide. Now the other structure is of the urea. You know very well that the urea has two amino groups in it, and the carbon is double bonded to your oxygen atom. But in case of thiourea, your oxygen atom is just replaced by the sulfur atom. So if you see the structure of your thiourea, so it is carbon bond to the NH2, another NH2 group. But in urea, this carbon is doubly bonded to the oxygen atom. But in case of thiourea, this oxygen is replaced by the sulfur atom. So therefore it is called as thiourea. And as its name indicates, the word thio means sulfur, and therefore it's in its structure the sulfur compound is already present. And now all the other structures are of the acidic compound. Okay, first is the benzoic acid. Now other acids are given below. First is the tartaric acid. So tartaric acid is the 4 carbon compound. First you have to draw COOH, then you have to draw 1 2 3 carbon, and this is the fourth carbon. So total fourth carbon you have drawn. Now at the carbon number 2 and 3 you have to attach OH and H group, OH and H group. So this is the formula of tartaric acid. If you want to draw the salicylic acid, again this salicylic acid has an aromatic or benzene ring inside its structure. So when you have to just draw the structure of benzoic acid. Okay, after drawing this benzoic acid structure, you have to add up OH group on the ortho position. Okay, so this will become the structure of salicylic acid. Now if you want to draw the structure of citric acid, the structure of citric acid I have also explained to you in the Krebs cycle, which I also called as tricarboxylic acid cycle. But here I again explain to you. So simply you have to do, first you have to do the make the carboxy group, then you attach CH2 group, then you write up a carbon and attach COOH group with it, and attach hydroxy group on its other side. Now again you have to attach CH2 group, and at the last end you will have to attach carboxy group. So this is a simply is the structure of citric acid. Now if you want to draw the structure of cinnamic acid, it is also simple and a little bit similar to the benzoic acid. What you have to do, you have to first draw the benzene ring, and then on the ortho position you have to make this a mountain like structure, then you have to again make this mountain like structure, and at it you have to draw double bond oxygen atom and hydroxy group, and you have to mention double bond at this position. So this will become the structure of cinnamic acid. Now we move on to the oxalic acid, and always remember, for the oxalic acid you have to draw two carboxylic acid and then join them. This is the structure of oxalic acid. And you also know the structure of glucose and fructose. I think I don't have to try to remember this. And sucrose structure you also know very well. You have to draw the cyclic structure of glucose, and you have to draw the cyclic structure of fructose, and then join them by the glycosidic bond. So this is the structure of your fructose. So I hope that you remember all the structures of these compounds. Then after you have remember the structure of these compound, now we move on to the practical of forming compound. So first you have to mention the physical state of these compound. So the one of the most common things in all of these compound, that all of these compounds are crystalline solid. So first thing which you mentioned in your practical is their crystalline solid like nature. So all of these compound, whether but the compound is given to you, you have to write crystalline solid, because all of them are crystalline solid in nature. Okay. Now second thing is came is the color. Okay. All the other compounds are colorless, but there is a exception of only one compound. Okay, which is cinnamic acid. The color of cinnamic acid is the creamy color. So except the cinnamic acid, all the other compound, whether it is benzoic acid, oxalic acid, glucose, fructose, sucrose, whether the compound it is, it has no color except the cinnamic acid, which has what color? Yes, very good, it has creamy color. Now we come on upon the second physical state, and this state is the odor. It means what is the smell of a particular compound. So all the other compounds are less odorless except benzoic acid and cinnamic acid. So the benzoic acid has very pungent smell, irritating smell, but the cinnamic acid has honey like smell. So these are only two compounds which has some odor in them, while the other all the compounds, whether it is benzamide, urea, thiourea, tartaric acid, salicylic acid, all other compounds are odorless. So now we revise what we have studied till up. So first we say that the physical state of all of these compound is crystalline solid. Yes, very good. Second thing we have remember, what is the color. Color of all the compounds is colorless except one compound, and this compound is cinnamic acid. You have to learn that cinnamic acid color is creamy color. Second is the order of these compounds. So only two compounds have different order, while other all of the compounds are orderless. So these two compounds are benzoic acid and cinnamic acid. So the odor of a benzoic acid is very pungent in nature, but the odor of cinnamic acid is like honey. So now we move on to the second thing, which is solubility, that whether these compound are soluble in water or not. For the solubility, all the other compounds are insoluble in your water, but the exception for these compound, your benzoic acid insoluble in hot water only, and NaOH and alcohol, but it is insoluble in your cold water. Salicylic acid is totally insoluble in your water, and cinnamic acid is supremely soluble in your water. Otherwise, except of all of these three compounds, all the other the organic compounds are soluble in your water. Okay. So for solubility, you have to again remember the three compounds, and you have to remain benzoic acid and cinnamic acid. The exception of benzoic acid and cinnamic acid is also occur in the order, but in solubility another addition occur of salicylic acid. So salicylic acid is totally insoluble in your water. Okay. Now we move on to the next test, which is the ignition test. So in the ignition test, what you have to do, you have to take your compound, put on the back tip of your spatula, and then you have to take this spatula toward your Bunsen burner, and you have to burn that compound. And after burning that, you have to notice the flame which coming out of the compound during the burning process. So the color of flame and the appearance of flame will define whether the compound is aromatic, whether whether the compound is aliphatic, whether the compound is saturated or unsaturated. So we have four cases which could occur in the process of ignition. First, your smoothie flame can occur, sooty flame can occur, and always sooty flame occur due to the unsaturated compound. What are unsaturated compound? Unsaturated are the compound which have double bond in them. So now we see what are the unsaturated compound in the above mentioned compound. So firstly, you see the benzoic acid. In the benzoic acid, we have a benzene ring, and in the preparation of benzene ring we have three double bonds, so it means it has a unsaturated compound. Now we move on to the benzoamide. In If you see the benzoamide, it also had benzene, so it is unsaturated. Now if you see the structure of urea, that carbon and oxygen has double bond between them. So the double bond is representing that it is also unsaturated. If you see the thiourea, now you tell me whether thiourea is saturated or unsaturated. Yes, of course you are right. The In thiourea there is also a double bond, and where the double or triple bond is present, we say it is unsaturated. So thiourea is also unsaturated. Now I have a test for you, and you tell me whether the tartaric acid is saturated or not. The structure of tartaric acid is present on the screen, so you can tell me whether it is aromatic, or sorry, whether it is saturated or not. So yes, you are given the time of 5 minutes, and after 5 minutes you have to tell to me. So stop the video and tell me your answer in the comment section. So I will see the answer of your tartaric acid in the comment section. Okay, I know the answer, and yes, you have said the right answer. Tartaric acid is also unsaturated compound. Why? Because in the tartaric acid, the group COOH group is present. And how this group is formed? If you see, there is C double bond O and OH. There is a unsaturated in it. So tartaric acid is also an unsaturated compound. If you see salicylic acid, again a benzene ring is present, and it is also unsaturated. If you see the citric acid, now citric acid also has carboxyl group, so it is also unsaturated. Cinnamic acid, again it is an unsaturated compound. Or oxalic acid, it also unsaturated compound. But in the case of glucose, you see, yeah, glucose is also a unsaturated compound. Why? Because the aldehyde group on the top of this benzene ring, glucose, this is aldehyde group, and aldehyde group form like this. So it also had unsaturated in it. If you see fructose actually had it is. And in the case of sucrose, there is no, but sucrose is also considered as the unsaturated compound because it has this ring in it. Okay, so it's mean, what is mean by it? It's mean all of these compounds are unsaturated. So whenever you burn these compound, always a sooty flame is going to appear. Okay, and why there is appearance of sooty flame? Why another type of flame doesn't appear? It is therefore because whenever you burn your unsaturated compound, they are burned unpartially, means they don't completely burn out, they partially burn out. So due to this partially burning, there is the appearance of a sooty flame. Okay, now the clear flame will be noticed by you for the saturated compound. We have no saturated compound here, so therefore you will get no clear flame out of any compound. And the clear flame is also given by the aliphatic compound. Or one thing you have to mention, that all the aromatic compound having benzene ring in them, they also show a sooty flame. And why they are showing a sooty flame? Because of the high percentage of carbon in them. So due to the high percentage of carbon, they are giving you what? Sooty flame. Yes. But your aliphatic compounds and all the aromatic and sorry again sorry aliphatic and the saturated compounds will give you clear flame. Now you have to notice the color of this flame, whether this is the black flame, whether it is the white flame. So black and white flame also define whether the compound is aliphatic or aromatic. So why we are performing these tests? Because we don't know what is the compound is given to you. In the practical examination, you have given a compound and you don't know what the compound it is. You have to identify it, that what is the name of this compound by various tests. So in the ignition test you can know that what is this type of compound. So if the black flame coming out after the ignition test, so you will say that some kind of aliphatic compound is present in it. And if some white sooty flame is present, you will say some aromatic compound is present. Aromatic means some benzene ring. So its main benzoic acid, salicylic acid, cinnamic acid, and benzamide, they are going to give you black sooty flame. And in some compounds you can notice that there is the appearance of white flame. For example, if I give you example, so in the case of benzoic acid, you will surprise that when you burn it, it will give white sooty flame. Okay, but it show appearance of a black colored compound on the tip of spatula. Okay, when you see the tip of spatula on which you have to burn this compound, this tip of spatula appears blacky. So this blacky appearance is also confirm you that this compound is benzoic acid. Because in the case of glucose, for example, if you burn the glucose on the other spatula, glucose is also giving you white smoothie flame. But what is going to happen, it leave the brownie appearance on the spatula. Okay, so if the brownish color appear on the spatula, you will notice some kind of carbohydrate present on the spatula. And if black color is present on the spatula, then you will notice that some kind of benzoic acid is present on it. Okay, so now we discuss how the ignition test is going. Now we discuss how the litmus test. So if your litmus test, if you have some acid in your hand, for example, you don't know you have an acid and you wanted to know whether it is a acid or base, what you will have to do, you will take litmus test. For the litmus test, first you have to make the solution of that compound. You will take some amount of that compound, dissolve it in your water, and now you will take litmus paper or pH paper. Now you dip the tip of this litmus paper into your solution and then you came it out. After some time you will notice the color changing. If the blue color of litmus paper change into the red color, it's mean the compound is acidic. If the red color of pH paper is converting into the blue color, then it's mean your compound is basic. If a neutral compound is present, then there is a no color. Okay, no color will be appearance, means the litmus test is going to same, the color of litmus test is going to same. So what are these compounds? It could be a benzamide, it could be urea and thiourea. So it means that these benzamide, urea and thiourea is going to be neutral for the litmus test. And there are some compounds which show no litmus test because they are not undergoing this litmus test. And what are these compounds? This is glucose, fructose and your sucrose. So it means all the sugars are cannot perform the litmus test, while the benzamide, urea and thiourea, they are undergoing the neutral compound. Now we see what are in these compounds is acidic or what are in this basic. So if you see benzoic acid, so it has acidic nature, so it is going to turn it into the red color. Now if you see the urea and thiourea and benzamide, they are neutral. Now tartaric acid is also acid, so it is going to turn into red color. Salicylic acid is also acidic. Citric is a acid, cinnamic is a acid, oxalic is a acid, and the glucose, fructose and sucrose, they don't show a litmus test because they not capable of showing it. So we see that all the other compounds are acidic except benzamide, urea and thiourea because they are neutral compounds. And glucose, fructose and sucrose are the carbohydrates, so therefore they are not going your litmus test. So now we are going to discuss the test for the saturation and the test for the unsaturated compound. So we want to know whether our compound is saturated or not. So in order to know whether your compound is saturated or unsaturated, so you have to perform some tests. So we have three tests here. First is the Bayer test, then there is the bromine water test, because you are going to add the bromine water in your compound. And third is the bromine in CCl4, that you are going to add bromine in CCl4 in your particular compound. Now we see the result and the end observation of this test. First, for example, if you perform going to perform the Bayer test, so first you have to prepare this Bayer reagent. So for the preparation of Bayer reagent, you will use ammonium hydroxide and KMnO4. So by mixing both of these compound, you are going to produce your reagent. After preparing this reagent, you have to add up the particular compound in it, and you have to mix them, heat them for the 5 to 10 minutes, and then cool them under the tap water. After cooling it, you have to notice the PPT appearance, but you have to notice the color of PPT, whether it is brown or purple. If the brown color PPT appears, then you will be good luck, because if the brown color APPT appears, you will notice that your compound is unsaturated. So I have explained that all of these compounds here all are unsaturated. So it's mean that all of these compounds are going to give you brown PPT. So this test will be helpful to you, because in all of these your practical you have to appear the brown color. Second thing is, you have to if your purple color appears, for example, if you have some compound and it gives a purple color, then you will notice that this saturated compound is noticed. And you also have to know Bayer reagent has also purple color. So it's mean for the saturated compound, color is not going to change. Actually the purple color came from the KMnO4. The color of KMnO4 is purple, so therefore the reagent will become purple. And if you have a saturated compound, then this purple color remains same. And if you have an unsaturated compound, then this color is going to change into the brownish color. Okay, so now we move on to the second test, which is the test for the bromine water. Now how you prepare this bromine water? Very easy. You have to take some amount of bromine and add water in it, so you can prepare the bromine water. Now what you have to do, you have to take some amount of your organic compound, dissolve it in your bromine water, and the color of this bromine water is also brown. Okay, before bromine water and before brown. So what will going to happen, your if the decolorization occur, mean this brown color vanishes, this brown color disappear, mean this decolorization means that a fully watery like color appears. So it indicates that your compound is going to unsaturated. So as we have all the compounds unsaturated, so it's mean in the bromine water cells all of these compounds are going to be in the decolorization. Yes, very good. Now if another test is that the color remains same, means the brown color remains same and the brown color appears, then it means this is a some kind of saturated compound. Now the results are same from the bromine in CCl4, that if decolorization occur, the compound is unsaturated, and if the color remains same, then the compound will be saturated. But we have unsaturated compounds, so therefore we gain decolorization. Okay. And now one of the most important thing I have to tell to you, that why we are taking bromine water and then in this we are taking CCl4 in the bromine. Why we don't use the bromine water again? Because we have two types of compound. Okay, mention it in your mind. We have two types of compound. First, compound which are soluble in your water. Okay, and second are the compound which are insoluble in water. For example, the salicylic acid, this is insoluble in your water. Cinnamic acid is springly soluble in your water, means बिल्कुल lightly soluble है. And the benzoic acid is also insoluble in your cold water. So what will you have to do? Only bromine water test is performed by such compounds which are soluble in your water. okay, because bromine water also has a water in it. If the compound don't dissolve in it, but when how this reaction will occur? So therefore you have to make the compound soluble. So if the compound is not soluble, for example, if you have benzoic acid, you have salicylic acid, you have cinnamic acid, then you have to use bromine in CCl4, because these compounds are insoluble in water, and you have to use bromine in CCl4 test for the detection of saturated and unsaturated. Okay, I hope that you will understand this concept. So now will discuss how you will going to detect elements from it. So now I move on to the next page. So now we are going to perform the test for the detection of elements. So in this compound we have to detect only three elements. First is the nitrogen, sulfur, and then halogen. So you have to perform the test for the detection of all the three elements. First is the nitrogen. You have to detect whether the particular compound contain nitrogen or not. So for the nitrogen atom, what you will have to do, you have to take sodium extract. In all of these tests you have to take sodium extract. And what amount of sodium extract? 2 ml of sodium extract. Now after adding the 2 ml of sodium extract, you have to add up the dilute HCl, NaOH, and FeSO4. After adding them, you have to detect the color. If the Persian blue and bluish green color appear मतलब ये color appear हो जाता है, it's mean that your particular compound will contain nitrogen in it. And what compound show, for example, a benzamide compound, it has nitrogen in it. Second is the urea also has nitrogen. Thiourea, it also has nitrogen like compound in it. And other compounds have no nitrogen in them, so they are going to decolorize. So if the decolorization occur, it means your compound has no nitrogen in it. For the sulfur atom, you can perform two tests. First is the lead acetase test, and second is the sodium nitroperoxide test. For both of these tests, if the decolorization occur, it means sulfur is not present in a particular compound. And if the black ppt appear in the case of lead acetate, it means sulfur is present. And for the sodium nitroperoxide test, the violet and purplish ppt is appeared, so it means your compound has a sulfur in it. So sulfur containing compound is only thiourea. Okay. So for now, the next test is for the halogens. And for the detection of halogen, you have to put sodium extract and then HNO3 and AgNO3. Okay, for the sulfur detection, you have to add acetic acid. Okay, and for the halogen you have add up, and after adding the sodium extract, if you give a white or yellow ppt, it means your halogen is present. And if you get decolorization, then it means you have no halogen in it. And the compounds which we have given to you is contain no halogen in them, so therefore they give decolorization. Okay. Now in the next part, I have mentioned the melting points of all of these compounds. So you have to learn it or memorize the melting point, because in the confirmation test you have to write up the melting point determination. And when you know the melting point of a particular compound, then you have to detect whether it is this compound or this compound. So you have to learn these melting points. And now we will discuss the functional groups test in the next lecture, and we have also discussed the uh, conformation test in the next lecture. So that was enough for the today's lecture. Keep watching my videos. If you like this content, please subscribe my channel and like my videos. Now take care of yourself. Meet in the next lecture, and please subscribe to my channel, press the bell icon to get the notification of all the videos which I have uploaded. Thank you so much for watching this video. Thanks again, and take care of yourself. Allah Hafiz.